right, guys, welcome back. We have just finished chapter 7, all of it. I generally don't do chapter 8. I don't know why, but usually the fourth quarter, we really start talking about pre-cal topics, calculus. We're going to start thinking about that. So we're really just going to spend the next 2 weeks talking about some topics that we need to be more familiar with before we start pre-cal. We meaning you. So if I'm doing this, you're like, hey, I've got this, I know this, I remember this from Algebra 2, you don't have to pay quite so much attention. But I need you to be prepared with a few things before we start next year. Meaning, if some of this you're like, whoa, I don't remember any of this, oh my goodness, let me know. We can do some extra things for you because before we start next year, there's some things you need in your back pocket, okay? We're going to start with quadratics. First off, what is a quadratic? Okay? What is a quadratic? It is what's a good definition of a quadratic? It's a function that has an x squared in it, okay? It is a parabola, okay? It's a function, something like y equals x squared plus x plus 2, okay? A quadratic is going to have a squared in it somewhere. Actually, a quadratic could look like this. X equals y squared plus y plus 2, okay? The x doesn't have to be the one being squared. The y could be squared. As long as you have one thing squared, one variable that's squared, and the other is not, okay? So that's a quadratic. We will look at graphs. We will look at what they look like. How do we solve a quadratic? When I say, how do we solve a quadratic, what do you think I'm asking for? Okay, some of you may not know what that actually means. You've heard it, you've said it, you probably can do it, but what does it actually mean? You're looking for the x-intercepts, okay, or where the graph crosses the x-axis, okay? So you're looking for what does x equal, okay, when y is 0. Sometimes they're called the roots. You're looking for the roots of the equation. You're looking for the solutions. You're looking for the x-intercepts. So all those things, when they talk about that, they mean the same thing, okay? So we're going to talk today not about how to solve them, but I want you to know 4 different ways to solve a quadratic, okay? So I've got some equations, and we're going to take one equation, and we're going to solve it 4 different ways and get the same answer all 4 times. Miss Evans, I already hear you in the back of the room, maybe in the front of the room. If we solve it once, why in the world do we need to know the other 3 ways? First answer is because I say so. Because each one has an important piece to the knowledge of moving forward with other things. This you just have to trust me with, okay? So if I give you an equation, y equals x squared plus 5x plus 6, okay? First way that we're going to solve this. First, we'll just call it the first way. They're really in no order. There's just 4 of them. The first way, could we factor? Okay, personally, I love to factor. I'm going to see if every single thing will factor. But you know, just like I know, that not every function is factorable. Okay, you know that. All right, what about another way? Second way we're going to solve this. Yeah, I've said quadratic enough times. You're like, what about the quadratic equation. I feel like that's misspelled. Equation. Yeah? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You're welcome. Okay? You can use the quadratic equation. Plug it in. It gives you an x every single time. Works 100% of the time. Factoring doesn't, but I love it so much. Okay? So those are generally our two ways of doing this. The third way, which I know you've seen, some of you will tell me you haven't, but I know you saw it in Algebra 2, okay, is completing the square. Okay, this will be the one you like the least. It will end up becoming one that's very, very important. Okay, so if you don't like it, I may push you towards using it more often. It will work 100% of the time. Every time, always. Okay? And the last and final way, of course, this is what I do. Let's see if I can just scoot these. I can scoot them over. So I've got room for the fourth way. Okay, so the fourth way that we can solve a quadratic is using our calculator. Okay? It will give us decimal approximations. Now, the quadratic equation and equating the square will give us exact values. Okay? Exact values meaning those square roots, if they're there. A calculator will work 100% of the time, but it's going to give us approximations. Okay, and that's okay sometimes too. Okay, so 4 different ways. So I made one problem that can be solved 4 different ways. Are you ready? I know you are. You were born ready. Okay, the first way, factor. So I have y equals x squared. I'm not going to write it over and over again if that's okay. Okay, thank you. So y equals parentheses. Now, I don't know how you factor. You just have to know how to factor, or you can be confused when I try to explain how I factor if you're going to ask me. Okay? Coach King had a definite plan. He did not like the way I did it because mine is more of a guess and check. That's how I was taught. That's how it was ingrained in my brain. I look at factors of 6 that add to get 5. Okay? That works really easy when there's no number in front of the x squared. Okay? Because then I have to do other things. So, factors of 6 that add to get 5. I think everybody's saying 3 and 2. Okay? The fact that x is by itself, x times x is x squared. Everything's positive. It's so nice. That's so nice, Miss Evans. You are such a gem giving us this problem. And if I want to find the solution, so just factoring, does that give me the solutions? Remember we talked about the solutions of a quadratic. Finding the roots, finding the x-intercepts. No, it doesn't. We have to know x-intercept is when y equals 0. So then we're going to plug in 0 equals, and then I'm going to have my factors. Okay? And then from this point, we're going to set each piece equal to 0. So I have x plus 3 equals 0, and I have x plus 2 equals 0. Okay? I'm going to subtract 3. So I've got x equals negative 3. Subtract 2 from this, x equals negative 2. I have my solutions. That's a negative 2. It works. I have an answer. Yay! All right, should we stop? No, we're going to do it all 4 ways. So here we go. The next way, let's do it in a different color. We'll do green. Quadratic equation. It says x equals. And I'm going to go write out the formula and then plug stuff. Actually, I'm going to write out the formula up here. The quadratic is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? And where's your A? The number before here, your B, and your C. Okay? Here we go. Negative B, so negative 5 plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Okay? I'm sure you could do that and maybe not have to write out all of it, but I'm going to write out because we're just starting. So here we go. Let's scoot down just a touch. Negative 5 plus or minus the square root of, I got 25 minus 4 times 1 times 6. I'm pretty sure it's 24, right? All over 2. So here my square root, I've got to deal with this little piece right here. What's the square root of 1? It's simply just 1, right? So here we go. We have negative 5 plus or minus 1 divided by 2. So this is still x equals. I haven't changed that. So now I have two problems here. I have a plus and a minus that I have to deal with. Okay? So I have negative 5 plus 1 over 2. And I have negative 5 minus 1 over 2. So negative 5 plus 1 is negative 4 divided by 2 is negative 2. Negative 5 minus 1, add the opposite. I get negative 6 divided by 2 is negative 3. So x equals negative 2 or negative 3. Is that the same answers from the first? Yes, they're the same answers, Miss Evans. Then you know you've done it right. Okay, completing the square. This may be one you are less familiar with, okay? But I know you did it in Algebra 2. Completing the square, I had somebody explain it to me once, and they had this beautiful visual of a square, and they just needed that last little piece to complete it. And I've tried to teach it that way, and I don't remember it as well as I thought I did, I guess. But it's okay. I'm still going to do it because I still love it, but I just can't explain it the way they did. So here we go, completing the square. We have an equation. We're going to set it equal to 0. We're going to start with that, setting it equal to 0. Okay? So I'm going to start with 0 equals x squared plus 5x plus 6. And I might even put 0 equals 0 at the end. It doesn't really matter. Actually, I'm going to stop because I can be a little bit, I don't know, particular. I like the equal 0 on the right side. I'm sorry. So I'm just going to write it like this, equals 0, because I like it better like that. No reason whatsoever. You could use it both ways. But this is just how I like it. It makes a little bit more sense to me. So completing the square, what we are going to do when we complete the square, if there's a number, a constant that has no x with it, there's a 6, we're going to move it to the other side, meaning we're going to subtract it from both sides. Okay? So I'm going to end up with x squared, I'm going to run out of room, x squared plus 5x. I leave a space because I know what's coming. Okay? Because I want to complete a square, meaning I want this right here to end up as a perfect square. Okay? Perfect square. So, I know I need to leave a blank here, plus blank. And with every equation, if I add it to one side, do I have to add it to the other side? Yes, I do. So if whatever I add right here, I'm going to have to add on the other side. So whatever I fill in this blank with, I have to fill in this blank with. Okay? And I'm going to complete the square and have a perfect square. Well, how in the world are we going to have a perfect square? Oh, that was a little bit bigger eraser than I thought. Okay? So that's what we're going to do. When we are completing the square, we are always going to do a b over 2. b over 2 is the big piece, but then we're going to square it. What is our b again? In this case, it's 5. Okay, it doesn't change. So we're going to take b divided by 2, 5 divided by 2, and I'm going to square it. Okay? If I add 5 halves squared to one side, what do I have to add to the other side? 5 halves squared. Okay? Now, the wonderful thing about this is I can now factor. I have something where my first and my last term are both squares. Okay? There's something special about that when they're both squares and they add to be the middle number. Okay? So 5 over 2 plus 5 over 2 is 5. Okay? So we all know 5 halves squared is really 25 fourths. Yes? So we'll use that number in just a second. So when I factor this, it will always factor to x plus b over 2 times x plus b over 2, which is really x plus b over 2 squared. I just made the left side be a perfect square. Okay? Now, I haven't really dealt with the right side very much. Well, I need to, don't I? Because now I need this to actually be a number. Negative 6 plus, and I need to know 25 fourths. Well, how much is 25 fourths? And I need to have common denominators. I need to get a number for that. Now, I'm pretty sure 25 fourths is 6 and 1/4. So what is negative 6? So here I'm going into my little scratch paper. I've got a negative 6 and a positive 6 and 1/4. Okay, what am I left with? That's right, 1/4. Okay, I knew I would run out of room. So I'm going to scroll down just a little bit. Here we go. So now I'm at this equation right here. I have a perfect square. X plus 5 half squares equals 1/4. How do we solve for x equals? How are we going to solve x equals? Well, I would take the square root of both sides, right? The square root of x plus 5 halves squared is simply x plus 5 halves. Yes? Equals, what's the square root of 1/4? Square root of 1 is 1. The square root of 4 is 2. What do you have to remember? When you take the square root, you must have a, that's right, a positive or a negative. Okay? Now I'm going to add, sorry, not add, I'm going to subtract 5 halves from both sides. Okay? Now I have x equals. X is by itself. Okay? So what is, now I've got two problems here. I've got a positive 1/2 minus 5 halves, and I've got a negative 1/2, negative 1/2 minus 5 halves. Okay, what's 1/2 minus 5 halves? 1 minus 5 is negative 4 over 2. What's negative 4 over 2? Negative 2. Negative 1/2, add the opposite. I've got a negative 6 over 2. What's negative 6 over divided by 2? Negative 3. Did I get the same answer? Yes, I did. I already can hear you. But Miss Evans, that one was so much longer. Oh my gosh, why do we have to do that? Okay, I'm sure you don't sound exactly like that, but some of you are like, why would I ever do that? Number one, because I'm going to force you to. I'm going to make you do it. It's going to be crucial that you do. Period. End of story. You have to be able to complete the square. Okay? You have to. It's not an option. Okay? But one good thing is we generally won't have to go all the way to solve for x when it's really important. Okay? My last piece is using the calculator. I really don't need to write anything on the board. Okay? I'm going to go to y equals. I'm going to clear out all of that mess. And I'm going to put in y equals x squared plus 5x plus 6. And I'm going to hit You can hit graph. It will graph it for you. But I don't even want to know what the graph looks like right now. I want to know calculate. And I'm going to go down and find the zeros, the number 2. Okay? And I'm going to hit enter. It's going to graph it for me. So second trace, which is the calculate button. Okay, you see it right here. Second trace is the calculate button. Went down 1 to number 2 because I want to know what the zeros are. And now it's going to ask me about a bound, a left bound. So now I see where this graph is crossing the x-axis. When it's asking for a left bound, I have to take my little cursor and go to the left of where it crosses the x-axis. And I'm going to hit enter. It's going to kind of put a line there. And then it says, what is the right bound? And so I'm going to go to the right of where it crosses. Now, am I going to cross all the way over here? No, because there's multiple zeros. Okay, I'm just going to go to where it goes below. I'm going to hit enter. And it asks me, do you have a guess? You can move the cursor, but you don't have to. You can just simply hit 0. And it takes me to that 0. X equals what? -3. X is -3 when y is 0. We have that answer right here. Okay? Let's go back. I'm going to hit second trace. I think I made that bigger. I don't know what I did. Okay. Whatever. Second calculate. I'm going to go down to number 2 again. And I want to know where this piece is. So I'm going to go over to my left bound so it's below or in the middle where the graph goes below the y-axis, the x-axis. And then I'm going to do a right bound after it goes up. Okay? Doesn't matter how far. And then it asks me for a guess. This time I'm not going to move it. It's okay if you don't. I'm going to hit enter. And guess what? It's going to take me to the other 0. Okay? You're done. That's it. That was one problem. We'll come back tomorrow and do some more and some more different things. Okay? Actually, maybe I give you one problem. That's what we're going to do. You're going to have one problem to see. Can you solve one problem 4 different ways? Meaning I will not accept just an answer. I have to see your work. Except for the calculator. That's pretty much self-sufficient. If it works, it works. Okay? Here we go. We're going to do a y equals 2x squared plus 3x plus 1. Okay? Can you factor with a number in front? Maybe you do a different one first. That way you get your factors. It's up to you. All right, so I want you with this equation to solve this quadratic 4 different ways. Go back and re-watch what I did when I completed the square, okay? You don't have a book to look at. I'm sorry. Khan Academy. Go Google Khan Academy for completing the square. He'll explain it to you probably better than I did. He may even have that visual. I don't think I've seen it on there, but maybe I will attach that. That's a good idea. Yeah, I'm going to keep that idea. All right, guys, you are great, and we will talk to you again. Bye.